Hey guys, so today we're going to do some more with solving equations. And so I posted this question as your quick little intro to today's lesson, where I'm asking you to write in a number so that I would keep this scale in balance. So a lot of you typed in a couple or wrote in a couple different numbers. I saw 1 equals 1. I saw 7 and 7. I saw 24 and 24. A couple of you also did like 2 and 2. And so my question here is how many possible answers or how many numbers could I put into the boxes so that it is the same number on either side that would keep me in balance? And what you guys told me was that we'd have infinite numbers of solutions. And why is because there's an infinite number of numbers. Right? So I could have chosen any number I wanted to go in both of those boxes. All right. Our second idea that we brought up was we had this scale. And you guys noticed that I had 3 boxes on the left, but only 1 box on the right. So to make these equal or keep them in balance, there is only one number that would work here, and it's 10, so that it would be 30 on the left and 30 on the right. So what we say here is there any other number that I could have put in those boxes? Remember, they have to be the exact same number in every box. Is there any other number that would make that balance? And the answer is no. This guy has one very specific solution. 10 is my solution in this case. Only 10 would work to make that level balanced. All right, and here's my last possibility here. So based on what we see, we should be writing 20 in all of our boxes to keep them the same number in each box. But we end up running into a problem here because 40 in comparison to 20 is a lot heavier. That's not equal. That's definitely not balanced, which means that 20, is that an actual solution? And our answer is no, because I am not in balance. It's a number that does not make this make sense. Now, another way we could say this is that 40 is not in equal balance of 20. All right, so to sum that all up, when you're solving equations, guys, you can have 3 possible things happen. One will be you actually get an answer out of the equation. X will equal some number. May it be 10, may it be 5, or something along that lines. The second option is you have no solution because I get 2 things that are not of equal balance. They are not equal to one another. Or you have this third option, which is infinite number of solutions, which means any number goes, aka the number will have to be in balance on both sides. So what we're going to do is we're going to actually use our solving process from before, and we're going to do 4 examples together. So if I literally take a look at example 1, a lot of you would go, okay, Miss Weldy, can't I just type that into Desmos? And if I do try to type this guy into Desmos, please take a look here with me, the fact that I don't see anything graphed. And even as I zoom out really, really far, guys, I still don't see anything graphed. That's a trigger in your mind that this can't be one solution. And why that's a trigger is because you don't see anything graphed. So we're going to have to go back to this guy and do it the old school way, which is to actually solve it by hand. All right? So to solve by hand, I want you guys to pay attention to some of these things that look alike. In particular, I noticed that I have an x and a 2x. If I combine those like terms, 1x plus 2x's now makes 3x's on the left plus 5. And we're going to do the same thing over here on the right side because positive 2 plus positive 3 ends up giving us positive 5. Now, right from the get-go here, we can stop here because I see 3x plus 5 is literally equal to 3x plus 5. If these guys are literally equal to one another, it means we will have an infinite number of solutions. Now, if you don't believe me, I could also take away that 3x on both sides of my equation at this point. And when you take away that 3x take away 3x is no x's anymore. And same thing on the other side, which ends up leaving us with a statement, 5 equals 5. So in fact, I'm still an equal statement that 5 is equal to 5. Therefore, we have an infinite number of solutions. Pretty cool, huh? All right, so let's take a look at example 2. I see parentheses. So the first thing I would do is distribute or multiply to get 5x plus 5. And now we need to look at what can we move around a little bit. So notice you have a 7x on the left and you have a 5x on the right. In order to move this positive 5x, we're going to do the opposite. We're going to undo it by taking it away. Why I choose the 5x is because it's smaller, and 7x's minus 5x's give you 2. Now we can solve this like a normal equation. So we want to get that minus 3 away from our 2x. So not take away 3, but add 3 to both sides, and 5 plus 3 is literally 8. We're going to finish this guy up by not multiplying by 2, but dividing by 2. So we end up getting x equals half of 8, which is 4. By the way, guys, that means that this is one solution. And in fact, you could have graphed this in Desmos to get that solution. So only x equals 4 would make this a proper solution to this equation. All right, let's take a look at the last 2 examples. So I see parentheses, so I'm going to distribute through that negative 2. So I get negative 2k times, and then multiply negative 2 times 5, which gives you negative 10. When you do this, guys, I see a 3k minus a 2k. Everything else stays the same. And now we need to undo the k. So right now the k is positive, so to undo it, we take it away. Now, if I take away that k on both sides, there are no k's left, leaving us negative 10 equals 6. Now, guys, truly, is negative 10 equal to the number 6? No, it's not. Those guys are not equal, which means this is not infinite number of solutions. This is literally no solution. So no solution for this guy because negative 10 will never equal positive 6. All right, let's look at number 4. I see some parentheses we can take care of first. So we end up getting 6x minus 6 times 4, which is 24. And now I look to see if I can combine anyone. Can I get anything together here? And it does look like I have a positive 2 and a negative 24, which would make a negative 22 on the left. And now let's look on the right side. I see a 3x and another 3x that we can combine like terms, CLT. So if I take 3 x's and add 3 more x's in, I now have 6 x's. Minus 18 on the right, that stays in. And last but not least, guys, I get down to this step where I just have x's and numbers. So I'm going to undo this positive 6x by taking it away, both sides. When I take away 6x, there are no x's anymore, leaving us with this last statement. So is negative 22 literally equal in value to negative 18? And I'm hoping you guys are going, that's not even the same number. That's not equal. And if I'm not equal or if I am not in balance, then you have no solution that's happening. All right, everybody, it's time to practice.